Okay, well, my solution, and it turns out the units work out, so I'm reasonably confident in the solution. Let's go through the steps, and thanks once more to our detail person for pointing out a little error I made in the process, and we certainly hope to have him on the team when we send a spacecraft to Mars, so we don't accidentally use pounds for kilograms. Okay, because he would be the one to catch that. Okay, very good. Now, okay, so assuming drag force negative delta V squared, then we get the equation which has a very straightforward solution, and that's here. I'm not going to go through the details of that solution unless somebody disagrees with those steps, okay? Then we substitute V of 0 equals V naught, and I could have let T equals 0 to start with, but I wrote out the whole thing. And then I took the reciprocal of both sides, and I got this, and that's, okay, now T is 0, which I should have used in the beginning, so that C is 1 over V naught. So our equation, or our solution becomes V equals 1 divided by C, which is 1 over V naught, plus the delta over MT, which is here. And then we simplify it. I simply multiply both the numerator and denominator by a common denominator for these two things, in other words, by V naught M, and I get M V naught over M. I'm not going to read it to you. This is what I get, okay? Then I check out the units because I'm never totally secure, okay? And as you see, that's for very good reason. Now, what are the units of this? Well, if I just go to our familiar SI units, I have units of delta, which is newtons over squared meters per second, so that when I multiply delta by V squared, I get newtons over squared velocity units multiplied by squared velocity units, which will give me my newtons, or my force unit. And then that's times the units of V naught, which are velocity units, times time units, seconds, right? And that all comes down to kilograms, and it's very straightforward, okay? The meters per second divides this, and I have newtons over meters per second, and that's going to give me kilograms per second. Multiplied by seconds gives me kilograms, and it better be kilograms because this is kilograms, right? This has to have units of mass to even make the denominator possible, okay? I have incompatible units in an addition otherwise, and that can't be. And then, of course, I'll have then units of mass here, divide the units of mass here, giving me units of velocity, which I'd better have here, right? So here we have it. Here's our velocity function, okay? Now, what do we do with that?